What is up, mathletes? Welcome back to the episode of Math with Dr. Matt. And today, we're going to hit those reference angles. Don't go anywhere. All right, mathletes. So to help us with these reference angles, first of all, what the heck is a reference angle? So let's make sure you understand that before we get too deep into this video. So let's say they give you some alpha, some angle, right? And that angle is beyond this first quadrant. So say it's in the second quadrant here, right? So what a reference angle is, think of it this way. Wherever you stop, right? So they give you an angle and then you stop. This is called your terminal side. So when you make an angle using that terminal side and the x-axis, so this angle that's made right here, this is your reference angle. And the thing I like to remember is reference angles are always between 0 and 90 degrees. They're always going to be an acute angle, right? So between 0 and 90 degrees. And so this angle right here, we could easily see that it's between 0 and 90 degrees. So it's always, one side is going to be the x-axis and the other side is going to be made from this terminal side of the given angle. All right, so that's what a reference angle is. Let's say they gave you one that and then an angle and you ended up over here, right? So the reference angle would be this little piece right here if the angle ended right here, if the terminal side was right here. All right, so I'll draw some pictures for you so that this makes more sense. And so what I'm going to use is I'm going to use this table here to calculate reference angles. So if your angle ends up in quadrant 2, what you're going to do to get your reference angle is you're going to take 180 minus the given angle. If you draw your angle and it's in quadrant 3, then what you're going to do is you're going to take that angle they give you and subtract 180 from it. And that's going to leave you with your reference angle. But if you're in quadrant 4, like this picture right here, if you're in quadrant 4, you're going to take 360 and you're going to subtract the angle they give you to get your reference angle. So I'm going to do an example of these so that this makes sense. All right, I'm not going to leave you hanging. All right, so let's get in this. So our first question here, that's going to be in 3 parts. All right, so here's our question. What we want is we want to determine the reference angle that corresponds to each of the following angles. So for this first one, we want the reference angle associated with 165 degrees. And notice, this is going to be the same thing as if you're given the angle in radians. You deal with it the same exact way. But right now, I want to make sure that this makes sense in degrees. And again, you apply these same principles with radians. So check this out. If I draw 165 degrees, so I start here and I go 165 degrees, right? So this is my theta. So the angle they give you, the angle they start you off with, that's theta. So that's 165, right? That's not what we're interested in. We're interested in this angle right here, which is made from wherever you stop and then you go all the way to the x-axis. So this angle right here, this is your reference angle. This is what we're looking for, all right? So how do I find this reference angle right here? So according to that table that I showed you, you're gonna go with 180, since I'm in quadrant 2, you're gonna go with 180 minus that angle that they gave you of 165. And so that gives you 15. So this little angle right here, that's in red, right? That's 15 degrees. And that makes sense by just looking at it right there. All right, so hopefully this gives you a better visual. So there's our first example. All right, let's look at example 2. All right, so for example 2, this time they give us an angle of 249, all right? And we see here from our circle here, 249 is about right here, all right? It's off a little bit, but it's all good. So I draw my angle of 249, right? So this is a given angle. And what I'm interested in is, again, wherever I stop, I go and I make the angle. So this is my terminal angle, and I make it with the x-axis. So this right here, this blue angle, that's my reference angle. So wherever you stop, basically you look to the closest x-axis. So this is our closest x-axis here, right? So this is what we're talking about when we're talking about our reference angle, all right? So notice I'm in quadrant 3 this time. So what the rule says is when you're in quadrant 3, you take the angle that they gave you, that 249, and you subtract 180. And what you're doing when you subtract 180 is you're really getting rid of all this space over here. And you're leaving yourself with just this angle right here, which is what you want. That's what you're looking for, all right? So you take that 249, boom, and then you subtract the 180, and that leaves you with this reference angle right here, which we see is 69, all right? Making sense? Good. Follow me to example 3. All right. So example 3, what we have here is we have the angle 328. So if I draw 328, right, that's almost all the way around the circle. All right. So I stop here. So this is my terminal side. And so to make my reference angle, I just look at this terminal side, which is where it stopped, right? And I find the nearest x-axis. And so I connect the two, and this is my reference angle, all right? That's what I'm looking for. So the table said when you have the fourth quadrant, right? 1, 2, 3, fourth quadrant, what you do is you take 360 and you subtract the given angle, that 328, and that's what left us with the reference angle of 32 degrees, all right? So that's how we find these reference angles whenever they give you a given theta, a given degree, all right? So again, what's gonna help is if you really draw these first. And so later on, you get into more complicated cases, but again, you can't get into those cases until you really understand the idea of what the heck a reference angle is. So hopefully you found this helpful. Don't forget to like, subscribe, and we'll see you mathletes in our next video. Peace. All right, mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.